So, good morning, children. Let's start the class. We were doing smooth joints last week, and we started that past wave problem. The sum in 1990 paper. 1990 paper. I remember we drew the diagram, and we planned also 1990 question. It's about a hexagon. I remember we drew this diagram. It's about a hexagon hanging from A, and the shape, the regular shape is maintained using a light rod. This is LM rod. Yeah, now we have to mark the forces in the system. Weight of each rod, W. Uniform rods, each of weight W. Each of weight W, and in addition to that, in addition to the weights, this has the tension. Tension, rather, it's a thrust. Pt. And more importantly, we have to mark the reactions at these points component wise. Reactions, I'll mark say x, y, y here, but the system is symmetric about the vertical line passes the joint D. So at once you can say this y is symmetric, y is 0 due to symmetry. Get y is equal to 0, right? Okay, then mark at the other vertices. So this is x. There is no other horizontal forces until you reach this point. So therefore, the horizontal component should be the same x but in opposite direction. But you can say the same about this y component. I don't remember whether I marked here it is upward or downwards. And that can come downward. Make it. I mark some y1. So due to symmetry here also it has to be x, the same x in opposite direction, and y1. That's due to symmetry. I don't remember exactly whether I marked upwards or downwards. Anyway, now at the other on the other rod, it's the same x and same y1, but going upwards. Here also x and y1. Now you come to this joint. Now you come to this joint, then it will be uh, x here in this direction, but you can't say the horizontal force at this joint should also be x because there is another horizontal force. So it can be some other, say x1. I'll mark some x1 here, downwards some y2, then for equilibrium x1 in the same direct in opposite direction, same x1 in opposite direction, and y2 here also by symmetry x1 y2 x1 and y2. This angle is 60 degrees, this will be 30. You will need these 30 and 60 regular hexagon 30. Further, you are given the distance. Methanol, I remember. BLL here and M. This length is given at simple x. I remember we planned it. There are ways that you can do this. You have to find this T and simple x. So we need to get equations containing them. One thing is y equals 0. Yeah, you can consider this rod CD and take moments about C and directly find capital X, right? Having capital X in your hand, then you can consider this section, ABCD section, and take moments about A. When you take moments about A, this will not involve, when you consider the whole part, this will disappear, this will also cancel off, will In the equation will appear this W, of course T, simple X also, W and this capital X. But we find capital X first. Hmm? First find capital X, considering CD. We'll take moments above C. You get here it's positive W into. I'll take the rods of length, each of length 2A, everywhere. Now taking moments for CD about C, W into the distance is A cos 30. W into A cos 30. This one in the same direction, capital X into that distance is this 2A sin 30. 2A sin 30. Right? Plus capital X into 2A sin 30 equals 0. There is no other force because y is 0, right? It will not involve y is 0. So from this you can find capital X. You get like capital X equals minus W over 2 cos 30 over sin 30, that's cot 30. Capital X equals minus W over 2 cot 30. Cot 30 is 1 over root 3. Yeah, that is minus W over 2 root 3. That's what we get for X. Then as we planned, we will consider this section and take notes about A. Our the requirement is to get an equation containing t and x is also this simple x is also unknown. We need to find that also. So you get an equation containing two unknowns, t and x. You will need another then. But first, let's derive this. The second equation we planned, I remember. Second equation is you consider BC, B0 and take moments about B. So y1, when you take moments about B, these two will not involve because we are taking moments about this point, and y1 will not involve, y1 passes that. So in addition to tx, there will be only capital X. Again, here consider BC. Take moments about B. Take moments about B. You get t x into 2a. This is also rotating in the same direction. This is also rotating in the same direction. So we will say the moment is t into x plus tx equals 0. So you get like tx equals, capital X is known. When you substitute, 2 will get cancelled. You get, you will get like w a over root 3. Substitute from 1. Then we have to find t. That we need another equation because there are two unknowns here. We need another equation for which we can consider this whole part, A, B, C, D part, and take moments about A. Taking moments about A. Approximately unknown. Moments about A. About A. So these will not involve x1, y2, xy1. These will not involve. And capital Y is 0. This thing will be there. X, W, this W, T and simple X. Right? So now we are going to write moments. I'm taking in this direction. This is positive. So is this. So is this. These three W's rotating in the same direction, positive moments. X, when you pull it in this direction, you try to rotate in the opposite direction, right? Circularly, in the opposite direction. So that will be negative. This will create a negative moment. So will this. That will try to rotate the system in the opposite direction. This is negative, this is negative, but the other three are positive. So let's write plus W into, here the distance, A sine 60. W into A sine 60. Plus this W into the distance is this or this. That will equal to 2A sine 60. 2A sine 60. 2A sine 60 or cos 30. Same. 2A sine 60. Plus W into 2A sine 60. No problem, you can write cos 30 for that, right? This one, the same distance, the same distance as this, W into A cos 60 plus W into A cos 60. Then the other two, T and X. For T, the distance is, I'll write on the other side, T into, because T is rotating in the opposite direction, T into, what is the distance? This distance. Up to this, it is 2A cos 60 plus this part given simple X. This part is 2A cos 60, here to here 2A cos 60 plus you are given this simple X. So T into 2A cos 60 plus X. And there is this capital X also. That's also rotating in the same direction. Plus X into, what is the distance to that? From here to here. 2A cos 60 plus 2A plus again 2A cos 60. 2A cos 60 plus 2A plus 2A cos 60. Emang Ona manggil mana? 2A cos 60 plus 2A plus 2A cos 60. You can solve this these two equations and you will get the answer. In fact, two answers. Then on W sine 60 root 3 over 2 plus another W, not cos 60. This has to be sine. That's another 2 times of that plus that's another 2, altogether 4 times. W sine 60, 1, 3, 4. To the other side, x plus 2A cos 60, x plus A plus x. X we found earlier. X is this minus W over 2 root 3 into A plus 2A. A capital 1 plus 1 plus 2 will be 4. Solve this and get the answer. Expand करना A ආමම මොඩේට කරන්නේ. You can't divide everything by A because here it is just X, right? X is there. Make up the A තියෙනවා. මේක expand කරන්න පුළුවන්. මෙතන එනවා 2 root 3 WA plus TX plus TA minus WA over 2 root 3. I mean, sorry. Equals X into X into 4. මෙතනින් එතකොට 2W root 3A equals expand this TX plus TA minus 2AW over root 3. බලන්න කරලා ඉවර කරන්න. මේ TX එක ගන්න පුළුවන්. මෙතනින් Okay, finished it. So 2w root 3a for tx, you can substitute this w over root 3 plus ta minus 2aw over root 3, and a get cancelled. These two, you can cancel this, and this will go to the other side. You get t equals 2w root 3 or 2 root 3w. This will go to the other side and make it plus w over root 3. So altogether 6 variable number. බලමු මට මේ උත්තරේ ෂුවර් නේ. මේක නම් හරි වගේ. Do you agree? කවුද ඉන්නේ ක්ලාස් එකේ නම් දාලත් නැහැ කෙනෙක්. What about this? If you work it out, you get the same. කවුද ඉන්නේ බලන්න නම් දාන්න. මෙතන cos 60 plus x negative plus x into 2a cos 60 plus another 2a cos 60 plus 2a. මෙතන 4a නේ. මෙතන මම අරගෙන. නැකේ අරගෙන x into 4. W over 2 root 3 මෙතන උත්තරේ ෂුවර් නෑ ළමයි මට එන උත්තරේ. බලන්න මෙතන වුණාද කියලා. දානවා minus w over 2 root 3 a over 2 plus 60 1 1 4 හරි 2w over root 3 මට එන උත්තරේ විශ්වාස නැහැ කොහෙද වැරද්දක් තියෙනවා වගේ මම ආයෙ චෙක් කරන්න ඒක w into a cos 30 හරි මේක වැරදක් නැහැ. What 30 is 1 over tan 30. මේක හරි. මේක වරදින්න දෙයක් නැහැ. මේක ලේසි එකක් නෙමෙයි. tx equals x into 2a. හරි. මේක හරි. වරදක් තියෙනවා නම් මෙතන තමයි වෙන්නේ. හරි මේ ටික වරදන්නේ 1 3 4 4 times a sin 60 4 times a sin 60 sin 60 is root 3 over 2 එකත් හරි we will simplify that will do 2w over a then in the opposite direction you get t and x t 2a plus 60 plus x and plus x into make it than that. T times x plus a plus 60 is half that's a plus x make it x is this I substitute for x minus w over 2 root 3 x is minus w over 2 root 3 take a out so that will give 2a 2a 4a 4a ekatha 2w root 3a equals tx plus ta minus මෙතන එනවා 2wa over root 3 2wa over root 3 වරදකුත් නැහැ වගේ minus होने කොහොමද මෙතන x substitute කරලා x then for tx I'll substitute from this wa over root 3 එකක් තමයි අඩු වෙනවා minus wa over root 3 එකක් විතරයි then t is equal to then මොකද වෙන්නේ මෙතන 6 7w root මේක මට ෂුවර් නෑ මේ උත්තරේ 7w root 3 එක කියන්නේ මේක කොහේ හරි වැරද්දක් තියෙනවා කවුද ඉන්නේ කවුරුත් නම දාලා නැහැ තාම ක්ලාස් එකේ කවුද ඉන්නේ කවුද ඉන්නේ නම නම් දාන්න මොකද සචින් ඉන්නවා වෙන කවුද ඉන්නේ what about these things you agree you get these things get the same results and this one මට පේන්නේ වරදන්නේ අන්තිම උත්තරය වරදක් තියෙනවා මෙතන tx equals මම මෙතන ලියලා තියෙනවා හරි tx equals minus 2ax minus 2a x is this W to 3 minus AW over 3. Minus එක දාලා මම මෙතන කරන්නේ px equals minus minus x when x is minus so this will become plus. So AW over root 3 හරිනේ මම දාලා තියෙන්නේ AW over root 3. mistake එකක් තියෙනවා නම් මට පේන්නේ නැහැ මොනවාරි මම अरे මේක පොඩ්ඩක් අපි කියමු මෙතනින් mistake එකක් තියෙනවා නම් බලන්න right and you can substitute for t in this if you get the value of t from this substitute it here you will get simple x ඔතනින් උත්තරය ගන්න පුළුවන් උතුට්ටක් එහෙමට හදන්න මට කොහෙද mistake එකක් තියෙනව වුනේ නැහැ අපි මේකට වෙලා නැස්ත කරන්න ඕනේ ඊළඟ ගන්නට For homework, I then gave 2002, 2004. අපි තේරුම් ගන්න මේක වෙලා නැස්ත කරන්නේ පොඩි mistake එකක් තියෙනවා මේ plus minus චුට්ට බලන්න මාත් කියලා. මේක මම ගන්න උත්තරේ වෙන්න බෑ. Because with this you will not get the other answer. You have to show that x equals a over 6. උත්තරේ තියෙනවානේ. 3 root 3 w වෙනවා. 3 root 3 w. 3 root 3. तो मेरा 6 ආව නම් හරි. නෑ 6 නෙමෙයි. root 3 9ක් ආව නම් හරිනේ. 3 root 3 w is the answer. 7 නෙවෙයි 9ක් වෙනවා. එහෙමනම් කොහොමද? හරි. ඉතින් divided by 2. මෙතන 4 වුණා නම් හරිනේ. මෙතනයි ප්‍රශ්නේ. If you get 4 here, I mean 4 get cancelled and you get 2AW. මෙතන 2AW නැත්නම් 4AW ආව නම් හරි. एक माइनस होना ना मतलब माइनस में अरे एक टूटे करती है होगा मतलब 2 बना दे මෙතන 4 වුණා නම් උත්තරේ එනවා. ඒක චුට්ටක් බලන්න ඕගොල්ලෝ කරලා. We can go to the next question. එතන මොන හරි mistake එකක් නැතිනම් පාඩම තේරුණා නේ කරන දේ නේ. We go to the next question. Right, 2002. Question. Four equal uniform rods of W are really jointed at their to form a square. It's a square. The square is from the joint A. It's a square. When it's a square, it's always things are easy. It's hanging from A. These angles are 90 degrees and each part is 45 degrees. So it's very easy. If all the angles are the same 45 degrees, you will see the computations are very easy. Again, from A, and to maintain the shape, what do you do? Square shape being maintained by a light rod joining midpoints of lower rods BC and CD. Method. BC and CD කොහෙද? Midpoints. Yeah. Midpoints of lower rods BC and CD. Midpoints are connected by a light rod, as they say. That's basically the picture. Now we have to mark the forces, reactions, forces, the weights. Equal rods can be in it. Then the reaction here, mark with some other color. I'll mark X and Y in this also, but this system is again symmetric. So due to symmetry, again this Y will be equal to 0. Due to symmetry, y is equal to 0. Right? Uh, now we mark the other reactions. Here there will be the thrust in the rod x. X1 y1. You can't write the same x here because there is another horizontal force in the rod, right? So here x1 and y1 due to symmetry this also should be x1 and y1 due to symmetry you mark them symmetrically and x1 and y1. So all these angles are 45 degrees. Then another bit of thing. Calculate the thrust in the rod and the reaction at C. Reaction at C. We want to find the reaction at C. We already have written y equals 0. That means to find x and also t. Now we have to plan it. For this BC rod, if you resolve vertically, you can y is 0. We already found that. You will get y1. Knowing y1, you can consider AB rod and take moments about A. So this is the plan. If you first consider CD and resolve vertically, you get y1 directly because y is 0. Now knowing y1, you can take AB, consider AB and take moments about A. You will get x1. Knowing x1, if you take moments, if you consider this and take moments about C, yeah, consider CD and take moments about C. You can find T. Consider CD, taking moments about C. Since we know x1, y1 by now, you can find T. And finally, you asked to find the reaction at C. Reaction at C is x. Because y is 0, you have to find x. Now knowing T and x1, just for CD, resolve resolve horizontally, you will get x. It's a plan. And let's see whether there is anything better that we can do. ඕක තමයි පාර. අපි ඔය පාරේ යමු. So for CD resolve upwards. So upwards you get y is 0, right? So y1 plus w equals 0. Very easily you get y1 equals minus w. Then our plan, consider AB and take moments about A. Taking moments is very easy here because all the angles are 45 degrees. Taking moments for AB, you take moments about A. That's moments about A. W into A sine 45. this minus y1 into 2a sine 45 make a plus ne plus plus x into 2a cos 45 equals 0 a sine 45 or cos 45. Let the sine 45 down. We get cancelled. W minus y1. Y1 is again minus w into 2 plus 2x equals 0. Meaning x equals plus 2 minus 3w over 2. We found x1. It is x1, not x1. x1. Then our plan, you can find t. You consider there are B, C, and take notes about C. For B, C, you take notes about C, you will get T. बस मैं प्लान कर पे करा मैं मिनट देगा तुरंत देना इधर करा BC. Now take BC and moments about C happens. T into A cos 45 or sin 45 when it's 45 degrees. You can write anything. T into A, I write cos 45. And y is 0, only x will involve. W into again T is in this direction, W in this direction, S is in that direction. All three are in the same direction, right? Make that left hand direction. Okay, plus W into distance is the same. I mean, it can be sine, but 45 degrees value is the same. So W is the distance, A cos sine 45. For T, the distance is this, A sine of cos 45. For X, the distance is this, same direction, X 2A cos 45 or 2A sine 45. Equals 0. And then you substitute A cos 45 will get cancelled. And you can substitute for the other things. This is W plus X is minus 3W2 into 2 equals 0. For T we get 2W. T equals 2W, the answer. You have to find T first, then this capital X. Once you know T, for this plot, you can resolve horizontally and find X. Consider BC. For the rod BC, if you resolve horizontally, you get the x1 plus t all are in this direction. X1 plus t plus x equals 0. We can substitute for x1. X1 we found somewhere. Yeah. X1 is minus 3W2 plus t we found 2W plus x equals 0. So x will be equal to WO2. So the reaction at C, since y is 0, reaction at C is equal to X. Hmm? Also, we know that y is equal to 0. Therefore, the reaction at C is equal to X is equal to W over 2 horizontally. Direction is horizontal in this direction now, in the other direction. It depends, right? Depends upon the rod we are taking. If on BC rod it's in this direction, on CD rod it should be in the opposite direction. So next idea of 2004. Two 2004. This is question number 6A. AD, BC, CD are three uniform rods of equal weight and length, smoothly hinged at B and C. The AD, BC, C. The ends AD are hinged to a fixed smooth horizontal pins at the same level. The system hangs in equilibrium. AB, BC, CD are three uniform rods of equal weight and length, smoothly hinged at B and C. The ends A and D are yeah, hinged to fixed smooth horizontal pins at the same horizontal level. The system hang in equilibrium. If alright, AB and CD are inclined to the by the same angle, alpha to the horizontal. Alright, okay, it's some story like this. AB, BC, AB, BC, and CD. Each rod is of length equal weight and length. Say 2 and 2A. Name that W A W A W A, and then let's mark the reactions at the joints. X Y X Y. Due to symmetry, has to be the same X Y, but you can't say Y equals 0. It's not symmetric about the vertical line we are drawing through a vertex, right? Not through a joint here. It is symmetric, but you can't say Y is equal to 0. The same X, Y. And further, the question is about the reactions at A and D. At those places also it's hinged. Implementation of the reaction at A on AB. Reaction at A. Methane reaction again hinged. The X, it has to be the same X in the opposite direction because there is no other horizontal force, but there can be some other Y, say Y1, X and Y1. Alpha is the inclination of AB and CD are inclined by angle alpha to the horizontal. This is alpha. This is alpha, and beta is the inclination, the direction of the reaction, and beta is the inclination of the reaction at A. May angle like a beta. This angle is beta. Now we have to show that tan beta equals 203 tan alpha. Yeah. To find tan beta, we need to find x and y1. X and y1. You are asked to show that tan alpha equals something to tan beta. Tan beta equals something into tan alpha. Tan beta is the inclination of the reaction. To find tan beta, we need x and y1. Now that's a task to find x and y1. කොහොමද කරන්නේ? මේක ඇත්තට අමාරු වැඩක් නෙමෙයි. මේකෙන් නිකම්ම y හොයන්න පුළුවන් නේ. Just consider BC and take moments. Resolve vertically. You get 2y equals w. That is y equals minus w over 2. Then y හොයන්න පුළුවන්. Then you can consider this and take moments about this point. You can find y also. Sorry, x. X again. And if you resolve for this vertically, you can get y1. y1x. First consider this. BC resolve vertically, you get y. Knowing y, you can consider AB. Take moments about A. Since you know y by now, you will get x. Now knowing x and The other thing is consider AB. You can resolve vertically. Since you know y, you can find y1. Knowing x and y1, you can find tan beta. එච්චරයි පොඩි ප්ලෑන් එකක් තියෙනවා. මොකද විනා ඒක දාන පේන විදිහට නම් ගොඩක් ලේසි වගේ. Now stick to the plan. Considering BC, we solve upwards, get 2y plus w equals 0. That gives y equals minus w over 2. So it's very important when you mark things, mark with minimum unknowns, right? When you mark x and y here, you don't need to introduce something new here. Due to symmetry, they have to be the same. So you have to use them. If not, the question will be very hard. Things will be very complicated, very long calculations, many equations. අදාගන්න බැරි තරම් අමාරු කරගන්න පුළුවන්. Taman කැමති නම්. පොඩ්ඩක් මොලේ පාවිච්චි කරලා ඩයග්‍රෑම් එක අඳිනකොට කල්පනා කරලා කරා නම් බොහොම ලේසි. මෙන්න මේක පේන විදිහෙන් නම් ගොඩක්ම ලේසි. See how simple the equation also. And our plan then consider AB. Take points about A. ඔයගොල්ලෝ හැදුවේ නැත්නම් මම විනාඩි 5ක් දෙන්න try එකක් දාන්න. මම ගණන් අදනකොට copy කරලා වැඩක් නැහැ නේ. Here's the plan. You can do it. AB, we take notes about A. taking in this direction is positive, w into the distance is this distance a cos alpha. Hmm? And then y is rotating in the opposite direction, minus y distance is 2a cos alpha, minus y into 2a cos alpha. X is also rotating in the opposite direction, minus x into the distance is 2a sin alpha, minus x 2a sin alpha equals 0. Hmm? They get cancelled. For y we can substitute from this. We get w cos alpha minus y, that will make it plus here. 2 will get cancelled. Again w cos alpha equals, this will go to the other side, 2x 2x sin alpha. So that gives x equals 2w cos alpha over 2 sin alpha. That's x equals just w cot alpha. Dekat happen on ini w cot alpha. Number 1, number 2. Then now plan consider a, b, and resolve vertically. You will get y1. Resolve vertically. You get y equals w plus y1. wy1 coming down. Y is going up. We found y minus w over 2 equals w plus y1. So y1 equals minus 3w over 2. Then we want to find tan beta. So we have x, we have y1. Namely x, y1, x is positive. X is positive. X equals w cot alpha. I'm taking the reaction at this one. At this point over this point, it's the same. But for y1, I get a negative value. Therefore, it has to be going up. 3w over 2. Now the resultant. This, given that this is beta, so tan beta is equal to with the horizontal or vertical. The horizontal. Yeah. If you find tan beta will be equal to this over this 3w over 2 divided by w cot alpha. W get cancels. W. You get 3 over 2 tan alpha. Okay, yeah, tan alpha equals 2 over 3 tan beta. That's the answer, and that's what we needed. वो मिले सी है क्या? 2004. Then I gave a question from 2005 also. Next is 2005. Ari, shall we go to a 2005 question? 2005. ඒකයි තව එක දාන්න බැද්දම ඇති අපිට පාඩම. අර මම දාපු ටියුට් එකේ මේ මොනවද සමහරව කියවන්න බෑනේ නේද මම ඒක තව ටිකකින් හදලා දාන්නම්. ස්මූත් ජොයින්ට්ස්. ටියුට් එකේ මේ පොඩි අවුලක් කරන වර්ඩ්ස් වල සමහරලාට ඒක පර්සනල් බලලා මම හදලා තමයි PDF කරන්නේ. මේ ඒක ඒ වෙලාවේ සමහර තැන් වෙලා නැහැ මම ආයෙ තව ටිකකින් හදලා දාන්නම් දැන් 2005 ගන්න පටන් ගන්න කරමු. ඒ අතරේ මම ඒක හදලා දාන්නම්. Past paper problems anyway, my translations in the tutorial. Past papers before 2000. Right, now 2005 question. Somewhat similar to the previous one. But this time only two rods are connected to a horizontal beam. This is a horizontal beam. ABBC 2005 question. ABBC are two horizontal uniform rods of equal length 2A and weights W and 2W. Lengths are equal to W and 2W. They are smoothly hinged together at B and also hinged at A and C to fix horizontal beam. Hari? The rods are in equilibrium in a vertical plane with B below AC and CAB is alpha. CAB, this angle is alpha. Right now we have to find the horizontal component of the reaction at B. We have to find X here. But Y will be equal to 0. No, not 0. It's not symmetric, right? W and 2W, not symmetric. Therefore, you can say Y is equal to 0. You have to show that X is equal to 3W over 4 part alpha. And find the vertical component. At A and C, do we need to mark a triangle? Right? Yeah. We have to mark the reactions at these points. Depending on make a X known, X and Y1. At this point, the other side, X and Y1. Has to be the same X here. But you can't say the same Y1 because it's not symmetric. W and 2W, not symmetric. This Y1, this can be some other Y2. Up here, we have to find the horizontal component of the reaction at B and also the vertical component. This will also be alpha. Moments consider AB and take moments about A. You get an equation of X and Y. Then consider BC, take moments about C. You get another equation of X and Y. Two different equations because W and 2W are on either sides, not the same. If W and this is also W, then you will get the same equation by taking Considering this one and taking moments about AO, considering this one and taking moments about C, you will get the same equation if the system is symmetric. But this time it's W and 2W, so you will we can expect to get two different equations, and then you can solve them. Considering AB, you can take moments about A. So W into A cos alpha. This is in the opposite direction, minus y into 2A cos alpha. This is rotating the positive direction here, plus x into the length is 2A sin alpha, plus x into 2A sin alpha equals 0. And then I have to you can divide everything by the 2y cos alpha minus 2x sin alpha equals w cos alpha. That's equation number 1. Well, we have to when is 7 මෙතන 2w වෙන එක and all are the positive direction. Oh. Considering DC, taking moments about C, you get 2w into A cos alpha. All are plus 6 into 2A sin alpha. And this also plus 6 into 2A cos alpha plus y into 2A cos alpha equals 0. So you get another equation into 2x sin alpha plus 2y cos alpha equals minus 2w cos alpha. Equation number 2. When solve them, you can find x and y. Show that y equals scalar. X equals 3w over 4 cot alpha. When you find x, it has to be equal to 3w over 4 cot alpha. We will find x, and to get rid of y, and again to get rid of y, just subtract. Y will get cancelled. 2 minus 1. 4x sin alpha equals minus 3w cos alpha. 2 minus 1, right? Minus 3w cos alpha. So x is equal to minus 3w over 4 cot alpha. Cos or sin cot alpha. හරිනේ දීලා තියෙන උත්තරය. ඒකට ප්ලස් දීලා තියෙන්නේ. But that's determined by the direction. 3w over 4 cot alpha. හරිනේ. So magnitude is 3w over 4 cot alpha. Then the direction. Then find y. You can subtract and get rid of x and find y. No, to find y, these two you add. This will get cancelled. You can find y. 1 plus 2. 1 plus 2. Make up 4y cos alpha equals on the other side w cos alpha minus 2w cos alpha. That will be minus w cos alpha. This get cancelled. Y equals minus w over 4. That's the answer. This is the first answer. Next one ko y man ko hewa කොච්චරද දේව නේද? And find the vertical component. Take up part 2. if further the lines of action of reaction at A, C are perpendicular to each other. Make you again it's about the direction of the reaction at this point and reaction at this point. The next part. Right. Now the next. Oh, no, man, tutor them up hadala. Could you rather timne kamanga them because you can't read some letters in that PDF and I corrected it. Right. Now it's about the directions of the reactions at these 2 points. Given that they are perpendicular to each other. Perpendicular to each other. R1 and R2 are perpendicular to each other. Under this condition, we have to show that tan alpha equals 3 over root 35. Finally, we have to show that tan alpha equals 3 over root 35, and this is what we are given. So, we make beta ke lagatot, ek gamma ke lagatot. We know that beta plus gamma is 90 degrees, or beta equals beta equals 90 minus gamma ke lagagen monaha cell mandan. We found tan beta already. No, okay. Yeah, you can find tan beta, but for that you need y1. Again, you can find tan gamma. For that you need y2. Then we will see how to connect them. Well, to find tan beta and tan gamma, you need y1 and y2. You can find them easily, right? We know y. Yeah, we already have y. Then consider AB. Resolve vertically. You will get y1. For AC, AB resolving vertically, you get y1 plus w equals y. Okay, done on y, eh? So y1 equals y is minus w over 4 minus w, that is minus 5w over 4. Similarly, you can find y2. Consider BC, resolve vertically, you can find y2. Knowing xy2, xy1, we can find these angles, tan beta and tan gamma. For BC resolving vertically, you get all in the same direction. Y plus 2w plus y2 equals 0. Y plus 2w plus y2 equals 0. So you get y is minus w over 4 plus y2 equals 0. So y2 is equal to minus 7w over 4. Now we can find easily tan beta and tan gamma. Tan beta when x maybe minus y1, tan beta when gamma x, y1 should be going up. X is this. X is also negative. I mark this way. It should also be going away. Should be in this direction. Going up. Y1, 5w over 4. This angle beta. These two are in right opposite directions, right? So beta should be directed in the other way. So tan beta is equal to this over this divided by 3w over 4 cot alpha. W over 4 you get like 5 tan alpha over 3. This is number 3. We found tan beta. Then similarly, we can find tan gamma. To find tan gamma, x1, y2. Again, x is negative. So this x I have to draw in the opposite direction. W4 cot alpha. Y2 I mark downwards, but again you got a negative value for y, method y2. Y2 also we mark downwards, then it should be going up. Let's find tan gamma. This over this divided by 3W4 cot alpha. W4 will get cancelled. You get 703 tan alpha. That's what I get for tan gamma. Now we can connect them. Connect them. How? You are given that they are perpendicular to each other. That means gamma, you can say gamma equals pi by 2 minus beta. Since two reactions are perpendicular to each other, since R1 is perpendicular to R2, මොකද වෙන්නේ? You can say alpha plus beta equals 90, sorry, beta plus gamma equals 90, gamma equals pi by 2 minus beta, and we have tan beta and tan gamma. To connect them, we can take tan on either side. Tan gamma equals tan of pi by 2 minus beta. So that's cot beta. I think 1 over tan beta. And tan gamma tan beta අපි හොයලා තියෙන්නේ. Tan gamma tan beta හොයලා තියෙන්නේ. We can substitute for them. Tan gamma. I think 703 tan alpha. 1 over tan beta. Tan beta is this 5 over 3 tan alpha. මොකද වෙන්නේ මෙයා මෙහාට ගියාම tan squared alpha equals 9 over 35 tan squared alpha. So tan alpha equals plus or minus 3 over root 35. But alpha is an acute angle, surely. It can't be obtuse. Therefore, tan alpha has to be positive. Alpha is acute. That implies tan alpha is positive. So we take the positive value here, rejecting the negative value. Tan alpha equals 3 over root 35 only. එක ගානක් හදමු ළමයි. එතකොට ඇත්තට මට පාඩම ඉවර කරන්න පුළුවන්. So you can do the rest on your own. Let's question number in the tutorial. Question number 18. Question number 18 in the tutorial. It's from 1987 past paper, failure paper. Oh, mang wala din na. Let's read the question and draw. Try to figure out it and draw the diagram. Okay, numbers පාඩම ඉවරයි යා. මගේ පැත්තෙන් ඉවරයි. ඔයගොල්ලන්ගේ පැත්තෙන් තව වැඩ තියෙනවා කරන්න හදන්න ඕනේ. It's something, somewhat a special problem to like a system made by jointing rods smoothly placed on a smooth two smooth planes. Yeah, වෙනස් ගානක් නිසා මම ඒක අදමුගේ පරණ ගානක් වුණා. ඒකත් හදලා පාඩම ඉවර කරමු. ඒකේ වෙනස් එකක් කරලා බලන්න බෑ. Question number 11. Sorry. Dude, question number 11. 1987 question. Dude, question number 11. 1987. බලන්න අදින diagram එක. මේ ටියුට් එක මම ආයි දැම්මා දැන්. ඒක සමහර අකුරු පේන්නේ නැහැ නේ මම හදලා දැම්මා. හදලා දාපු එකේ පේනවා ඇති නේද? පොරත් ආයි චෙක් කරලා බලන්න. Now it's okay. You can read that the new tutorial, right? It's correct. The diagram. two rods jointed at this point B, I think, at AB and AC. Jointed at A, the system is placed on two inclined planes, and uh, these bottom ends are joined by a light inextendable string. එහෙම එකක් තියෙනවානේ. Ends here joined by a light inextendable string. Yeah. එහෙම නැත්නම් මේක blues කාලේ ඇතුළට වැටෙනවානේ. Right, to prevent that it's falling down, it's folding and falling down, so two ends are joined by a string. For ඇතුළට වැටෙන එක නවත්තන්න බෑ string එකකින්. එළියට විස්සලා යන එක නවත්තන්න. එහෙම දිගහැදෙන එක නවත්තන්න පුළුවන් by a string. ඇතුළට එන එක නවත්තන්න ඕන නම් you have to use a rod here, right? If the angle alpha is small, they will try to get apart. Bigger and bigger alpha, right? Bigger and bigger the alpha, they will try to get closer. So you can't prevent that happening that with a string. To prevent it with a string, you can prevent it's trying to get apart, right? So alpha has to be small. Then there is a tension in the string. So let's mark forces, reactions, and geometry. We are given this T, we have to find this T. W and W of equal weight. Yeah. Yeah. And the length, say A and A. Then we have to mark the reaction at this joint, smooth joint, XY, XY. And geometry, these are A and A. This angle is alpha. I have to mark the reaction at the normal contact force at this point. R and R. Due to symmetry, it has to be the same R on the other side because the system is symmetric. And මේ direction එක දාගන්න, that will be useful. The direction, this is alpha, 90 minus alpha, this will be equal to alpha. Alpha, 90 minus alpha, this will be equal to alpha. And further, you are given an angle. Angle is BAC equals to theta කියලා තියෙන්නේ. BAC equals to theta. 2 theta දීලා තියෙන්නේ. There should be some reason that they say 2 theta, not theta. 2 theta ගාම බලන්න ඕන ඇයි කියලා. This total angle is 2 theta, but it's divided into 2 equal parts. So each part is theta කියලා ගන්න. That's why they give 2 theta. ඔබ නේද කතන්දරේ? Yeah, that's the diagram. මම විනාඩි කිහිපයක් දෙන්න කල්පනා කරලා බලන්න. What are the questions asked, and if you can give some plan. කල්පනා කරලා බලන්න මොනවද කරන්න කියලා. So I have to find the tension in the string. I have to find tension in the string. That is T. Tension in the string we can find. We need to get an equation containing T. Uh, Finally, we need an equation containing T. To get an equation containing T, now you have enough experience to think these things, realize these things. You can't consider the system. If you consider the system, T will get cancelled. So you have to take one of these. Due to symmetry, we'll start by saying y equals 0. Due to symmetry, we'll take the advantage of that. Due to symmetry, y is 0. So we will get the advantage of that, right? Y is 0. And therefore, you can't take the system. You have to take one of the rods. Due to symmetry, whether taking AB or AC, it's the same. So let's take AC. And we want to find T. To find T, there are two options. To get an equation containing T, there are two options. You can either consider this AC and take moments about A. That's one option. The other is consider AC and resolve vertically. Definitely not horizontally. Definitely not vertically. If you resolve vertically, T will not come. So we have two options, right? Consider AB, take moments about A, or consider AB, resolve horizontally. If you go to the first option, AB and take moments about A, you will need, uh, in both the methods, you will need R. But if you take moments about A, you will need this perpendicular distance also. Negative theta, this is theta, this angle is theta minus alpha. මේ distance එක කියන්නේ 2a sin theta minus alpha. එහෙම එකක් උත්තරේට නෑනේ theta minus alpha. That means you have to simplify further. බැරි නෑ පොඩ්ඩක් කරදරයි. But when you go to the second option to resolve horizontally, before that you need t and x also. X හොයන්න නම් පුළුවන් you consider r හොයන්න පුළුවන් ඉස්සෙල්ලා. Let's find r first, then find x. In both the methods you need r. But in the first method, you don't need x. If you are going to take moments about A, you don't need x. In the second method, if you are going to resolve, you need x. In addition to R, you need x also. Okay, whatever the method, you have to find R. Let's do it first. What do you do to find R? To find R, the best thing is consider the system. Then this will get cancelled, T will get cancelled. We can just resolve vertically. For the system resolving vertically, you get R and W only. You can find R directly. For the system resolving vertically, R cos alpha, that is 2 times R cos alpha. That's upwards. Downward, you have W and W, 2W. That's equals 2W. This get cancelled. You get R equals W over cos alpha. You can find it very easily. We found R, then we need to find X if we are going to the second option. Then we need X. How to find X? To find X, we can consider AC and take moments about C. R will not involve. When you take moments about C, R will not involve, no T. but w and x will be there. With y is 0, so you can directly find x. Consider AC. අපි ලියන්නේ AC කියලා. අනේ. Considering AC, we'll take notes about C. Okay, we know W into in this direction, left-handed positive direction, W into A sin theta. This is the only other movement that will rotate in the opposite direction. So I can write equals x into the distance 2x. The distance is this. That will be 2a cos theta equals 2a. This into 2a cos theta. So you get x equals w over 2 tan theta. X equals w over 2 tan theta. Now our plan was to consider AC and resolve it horizontally. You will get T. For AC, if you resolve x, y, and you can find T. Resolve horizontally T. R cos alpha, R sin alpha. T plus R sin alpha. X is in opposite direction equals x. That's all. Name and name. T R sin alpha equals x. That's right. T by known. R is this. W over cos alpha into sin alpha equals x. X is W over 2 tan theta. මෙතන T one පුළ අම්මයි තමයි අපිට ඕන උත්තරය එන්න ගන්න. මේ තස් එක ලියන්න ඕනේ. T plus this is W tan theta. Tan alpha rather. W tan alpha equals W over 2 tan theta. මෙතන T හොයාගන්න. The answer is you can take W. You have to take W over 2 out. Take this to the other side and at the same time take W over 2 out. So W tan theta minus 2 tan alpha. උනතරේ. තමාරු නෑනේ පොඩි ගාන. මේක සම්පූර්ණ ගාන මොකද? පැය භාගයක් තියෙන ගාන. 1987 it's a half an hour question. මගේ පැත්තෙන් පාඩම ඉවරයි. You have to do all the sums from 2000 to 2020. එවනට කීපයක් දැනටම කරලා තියෙනවා. මේ past papers ඊට පරණ papers වල තියෙන අමාරු ගණන් මම හැදුවේ after 2000 also some hard problems. ඉතුරු ඒවා ලේසි. වැඩිපුර ලේසි ඒවා ඇත්තේ. ඒවා ඔයගොල්ලෝ කරන්නද? May itu may and apa pun itu No. Nel Vessero Vandegaran was no UBC left doon no. Oh. Left doon no. No, we will come on. You can say something අද ළමයි අපි එහෙනම් උතරින් ඉවර කරමු. මගේ පැත්තෙන් පාඩම ඉවරයි. From your side you have to do you need to practice, right? These are really sufficient, the examples I have shown. You have to for your practice do all this, and then from next week we'll start friction. Next week it's 11th. එදාට පාඩම කරමු. මම 18 වෙනිදා ඒ කියන්නේ 12 to 18th ඒ සතියේ විවේකයක් දෙනවා. හරිද? From 11th we will work with a different plan. මම plan කරමින් ඉන්නේ. ඕගොල්ලන්ට මම දැනුම් දෙන්නම්. අවුරුද්දෙන් පස්සේ වැඩ කරගෙන යන විදිය වෙනසක් වෙයි. ඒක අපි මම දැනුම් දෙන්නම්. දැනට එනම් අපි උතනින් නවතුමු ළමයි. ඔයගොල්ලන්ට බුස්සන්නයි.